And welcome everybody to the Daily Space Weather. I'm your host, Dan, aka smAsho. And we're looking at the sun in colorized magnetogram from the Solar Dynamics Observatory. You can see Sunspot 2826 about to set here. It will lose its name today. It has grown into a major sunspot. It's got two very large umbrae that are like the size of the Earth. Sunspot 2824, which trails it, will be setting soon as well. No other sunspots on the solar disk. Here's some more imagery for you. We did see a C7 class solar flare happen in the past 24 hours. We'll show you the graph of that, as well as a whole lot more data. This is 304 angstroms ionized helium. Here's 171 angstroms ionized iron. And we'll show you one of the other spectral states of iron ultraviolet light emission. It's 193 angstroms. Coronal hole rotating in over here. We finally see this North Pole oriented coronal hole showing up. And likelihood for coronal mass ejections is near 100%. There's a large plume of plasma down in this area, and it's about to erupt. It could produce an Earth-facing coronal mass ejection. It's sort of in the Earth vicinity. And if it does release, when it does release, I should say, we'll cover it. Here's a diagram of the solar system. There's where things will be in 1 week. Here's a star chart. For all of you stargazers out there, I like to use in-the-sky.org. You just put in your location, and what I'm using here is the all sky chart. There's a whole lot of other resources available for you at in-the-sky.org. The 10.7 centimeter radio flux, which is the output of the upper chromosphere and lower corona, now down to 83 solar flux units, having made it up to 88 briefly. Here's a 1 year chart of that. It's this black line. And there are no forecasts for any geomagnetic storms or unrest or anything like that. Here's the 3-day NOAA forecast. Let's take a look at global seismicity. What's the earthquake scenario? We only saw 2 5+ magnitude quakes in the past 24 hours. And we'll scroll up here, the USGS list. One of those was in China. It was a 5.4 magnitude. Tonga saw a small deep quake at a 4.8 magnitude, 108 kilometers. The Kuril Islands saw a over 400 kilometer deep quake. Japan saw a deep quake. Also a very shallow quake here near Davis, California. This one at 1,800 meters above sea level. A depth of negative 1.8 kilometers. And there's the location of that, near Lake Davis. Indonesia also saw a deep quake, as well as Dominica, seeing 2 minor deep quakes. Vanuatu saw a deep quake. That was one of the 5 magnitudes. And Afghanistan. So it looks like 3 5 magnitude quakes here. China, Afghanistan, and Vanuatu all saw 5+ magnitude quakes here. And the last 2 were both at depth. And that Afghanistan quake coming in at 7:24 universal time at a depth of 203 kilometers. Etna has been erupting as well. Here's the rest of the list of volcanoes. Kilauea still continuing to show activity, some seismic activity there, and some inflation of one of the lava domes. Halemaumau. There's a crater lake inside the crater Halemaumau, and I know you want to say it. Go ahead, say it. Halemaumau. Yes. Anyway, still activity happening at Kilauea. The Great Sitkin volcano in the Aleutian Islands, having produced an explosive eruption yesterday. And Novato State, Chilean were unable to detect whether or not it's erupting. Please don't take that as an opportunity to attempt to pole vault the caldera. It could be unhealthful. And don't consider yourself qualified to pole vault the caldera. At smAshomash.com, we give good advice. And here's this C7 class flare. We're looking back at solar data here, the sun-facing suite of instruments from the NASA GOES. The NASA GOES 16, it's the GOES X-ray flux here, and there's that C7 class flare. Peak flux on that was at 2310, so 10 after 11 universal time is when we saw the largest flare of the past few days, that C7 class flare, pushing the boundaries. It nearly was an M class flare. No spikes in the proton flux, no surprise there, as we haven't seen anything to produce one. It's one of the things we try to forecast. Also, the GOES magnetometer showing pretty low lows and low highs here, as the Earth is in a weak area of magnetism right now. And here is what's going on with the magnetism. So you're looking at the heliospheric current sheet and its polarity here. The top view ecliptic plane field plot shows you north solar polarity in green, south solar polarity in red. And the Earth could suddenly snap across here. We could see some pretty wild spikes in the GOES magnetometer from the current sheet situation. Which current sheet do you think the Earth will be in, North Pole or South Pole, when we do tomorrow's daily space weather video? Here's a line of sight ecliptic plane field plot. It also does include the solar magnetogram. And you can see how flat this blue line is here. That is a result of pretty much equal amounts of magnetic energy coming from both solar poles at the moment. Here's a line of sight coronal hole plot, and you'll see right at the end of this animation here, you'll see a little bit of green coming through. Down here, that's the coronal hole we showed you at the beginning of the video. This also shows you the sun's B field in blue. And here are the detected filaments and detected sunspot groups. Again, sunspot 2826 has continued to grow over the past 24 hours. 2824 remained pretty stable here. This area here, not a sunspot, although there was some umbra that appeared there briefly. No umbra when we did show prep. And again, I would remind you that there are some major filaments down in this area that are set to erupt. So we could see an additional Earth-facing coronal mass ejection. We'll keep you posted. And here's the last coronal mass ejection signature. That was a brief geomagnetic storm reaching a KP of 5. Nothing major there on the 26th. It was quite a bit weaker than forecasted. And just keep in mind, folks, that our specialty is forecasting coronal mass ejections before they leave the solar corona. It's a skill that I wasn't expecting to have, but here we are. We've done it repeatedly. We've demonstrated over and over again that we are indeed able to forecast coronal mass ejections before they occur. So let's take a look at the current state of affairs for the solar wind data. In the past day, we've seen a ramping down of the solar wind density all the way down to about below 3 protons per cubic centimeter. Solar wind speed still slightly elevated here at 432 kilometers per second. And here's a geospace magnetosphere movie. It's 4 hours of data of what's likely going on in the geospace. It's based on the space weather modeling framework, and we see this homogeneous area of magnetohydrodynamic pressure surrounding planet Earth right now. And this is a typical thing that we see after a geomagnetic storm. And you can see the bow shock region. The bow shock region losing some pressure here in the last couple of hours. You can see once again the main pressure here is in the magnetotail region. And let's look at ground magnetic perturbations. Since there's a polar excursion going on, we show this daily as well. It's one of the long-time features of the daily space weather. And we've been doing it about 3 years, a little over 3 years, I think, is about where we are now. This is also 4 hours of data. It's showing you changes in the Earth's B field, or geospace delta B, some minor perturbations there near both poles. I would also remind you that at times of geomagnetic storm, we can see major induction into the power grid, and the geoelectric field 1-minute model is one of the ways we can monitor that. This will show you the most likely spot of a thing like a power outage as a result of a geomagnetic storm. Calm conditions now, as we see the data corroborating. This is empirical data, and it is in the color shading there you see is in millivolts per kilometer. Calm conditions in the U.S. power grid. Next, we're going to do a cosmology segment, and we're going to stream live for Twitch for it. It'll be separate from the daily space weather video. And let's continue on with the daily space weather video. We've just completed the cosmology segment. Don't forget to check that out. All of you stargazers. Next, we're going to talk about things like electron flux. Here's a diagram of the Earth Van Allen belts, along with distances to things like satellites in miles. We don't see any charging hazards right now, as a lot of electrons in the Van Allen belt region can charge up satellites and cause communication errors. Here's a 1-year chart, and you can see we've seen a precipitous drop-off here of the electron flux over the past 24 hours. And here you can see, indeed, that dip in the electron flux, briefly making it into warning levels here on the 26th. Now, quite low levels of electron flux. And you can see the NOAA forecast missed. The green box was the forecast, and we saw much lower levels than that, similar to what we would see during a coronal hole wind stream, actually. And the forecast is for a small uptick there. I won't argue or make a forecast in this case. So we see some chaotic electron flux anomalies once again. And we regularly do see anomalous amounts of electrons here. This is the electron density you're looking at. And I would note at this moment right in here, right at the beginning of the video, we see some very dense regions of electron flux over places like the Indian Ocean and Central Africa. And some significant GPS errors likely to be happening in places like the Central Pacific and Central America here at nighttime. So we typically see the electron flux, we typically see the locations of the electrons here become much more chaotic at low levels of electron flux and more organized at more moderate and higher levels. You're most likely to see, strangely, GPS errors at nighttime when we have low levels of electron flux, not high levels. In any case, here's another diagram of the atmosphere. It's showing you things like the temperature of the thermosphere and the penetration of electromagnetic radiation and the different layers of the ionosphere, like the D layer, which is where radio blackouts occur when we see a solar flare, and the F layer, which is where the electron flux gets measured, by the way, around 300 kilometers of altitude. And here is an animation of this. Give it a minute to load. And this is 2 days of data at 2 hours per second. And we're seeing some significant anomalies here in the ionosphere as well. So I'm just going to let this play through. If you don't look at it every day, I don't know really how to explain it, other than that this isn't quite the fully normal ionosphere map that we would typically see. We're seeing very low frequency regions in the southern hemisphere, which is fairly normal as winter is approaching for the south, but we're seeing some rapid charge ups and charge downs. And we would expect to see the highest frequency regions north of the equator here as Northern Hemisphere summer approaches. Anyway, again, that's 2 days of data. Here's the latest image from 9 o'clock Universal Time, and we can see once again some anomalous charge downs here. That area making it down to 4 megahertz. That is usually a more charged up region. Trailing the sun there. Next, it's time to do a meteorology segment. And welcome to Twitch. We've brought you back for our meteorology segment. This will be fairly brief. Let's get to it. First thing we're going to do is look at the Earth's jet streams. Here are the jet streams of planet Earth. It's the eastern portion. And we're seeing a little more coherent jet stream in the northern hemisphere. Doubled up jet streams with some meridional jet stream flow in the southern hemisphere. And for you new viewers, meridional jet stream flows when the jet stream flows like this instead of like this, traveling parallel with the meridians as opposed to parallel with longitudinal lines. Some turbulent jet streams here over the central Pacific Ocean as well. Let's show the surface winds. As India has taken some damage on its eastern coast, we showed the tropical system as it was happening. Anyway, there are the surface winds, some strong winds off the southeast coast of Australia. Here are the surface winds of the western world. And here are the jet streams. The jet stream is probably the best single data point if you wanted to have some insight into global weather patterns, folks. And quite a chaotic series of jet streams here over the western world's northern hemisphere especially. Jet streams all broken up and doubled up and tripled up over places like the U.S. and the North Atlantic. By the way, if you didn't check out our severe thunderstorm onset video, check that out. Here's a tidbit.
Could be bad.
It sounded like there were trains in the sky, folks. There was quite a significant thunderstorm coming in. And we didn't get hit that hard. I was getting a little bit worried about some hail showing up. Fortunately, we didn't get any hail. And there could have been some funnel clouds up there. We heard sounds that sounded like freight trains coming out of the sky. So we've got some terrestrial lightning here. I'm on lightningmaps.org, by the way. lightningmaps.org. And we've got some thunder at Dallas. Hey, Dallas, there's thunder rolling in. Yowzers. If you're in Dallas, go out and look to the south and southeast. Maybe take some time-lapse photography. You may get some photos that are worthy of being on spaceweather.com. If you get some pictures of sprites or green elves or purple horseshoes or green diamonds or other lucky charms above the thunderheads. And if you use a camera to photograph those sorts of things, you may see things that the naked eye cannot see, as a lot of that is in the UV spectrum. Anyway, here's the lightning mapper. You can see some lightning here over Texas, Arkansas, Tennessee, moving into Mississippi here and Louisiana as we make the video. And here's the webcam at Etna. Yes, the webcam at Mount Etna. And this is located at Catania, basically right at the base of Mount Etna. And we do see some eruptions there on the webcam. Little bit of eruption right there showing up in the time-lapse photography from Catania. And let's zoom out and show pressure. We were on sulfur dioxide there. And the windy.com maps allow you to look at sulfur dioxide if you like. Here's where pressure is now. We've got a low pressure here south of the Great Lakes in the U.S. Let's advance this into tomorrow. Here's where we expect pressure to be tomorrow at 12 noon Eastern Daylight Time. And we're expecting very cold temperatures to roll in to the mid-Atlantic states. We're located in Lehigh Valley, Pennsylvania, by the way. Here's the U.S. Doppler radar map. And you can see that strong line of storms in eastern Texas stretching up to southern Illinois. Some heavy rains in Illinois as well, about to move into Indiana as we make the video, and some snow falling in northern Wisconsin. Once again, we're almost in June. Snow's continuing to fall. Is it a year without a summer? Oh my God, the planet must be so hot that it's cold. Here's what's going on in the cloud layer. And here's the water vapor map. We'll rock that back again. And all that moisture is taking its good old time, and it's getting sandwiched in between two areas of dry massive air. As you can see, here's dry massive air, and it's creating this channel of moisture. And those massive pressure gradients are responsible for that violent weather sweeping down into Louisiana as we make the video. And that's today's meteorology segment. We'll have to say goodbye to Twitch as we do bonus features for the daily space weather. And here are said bonus features. How about the latest data from El Teide, Spain's ground-based solar observatory? And you can see some of the filament down here that we were talking about. Expect to see this release from the corona in the next 24 hours. It could be an Earth-facing coronal mass ejection. It could be not. This area up here is a plage. There is also a filament up in this area. But this is the one that's going to erupt down here. And how about some high-res images of the closest star? Here's Sunspot 2824, which is this one, and 2826, which is this one. It's going to lose its name today. 2824 will lose its name maybe later today, possibly tomorrow. Here are the magnetic fields. Again, no other sunspots here. The heck is going on? There we go. No other sunspots currently on the Earth-facing disk. And we've got two more close-ups of the northwest. To close things out, here's 193 angstroms and a great Earth scale to show you the size and scope of those sunspots. Also a view of the north solar polar coronal field region, coronal hole region rather. And we'll close things out at 171 angstroms. Thanks for tuning in, folks. Remember to stare at the sun. Use our channel to do so. Don't drink, and if you do, don't drive. Seriously, don't drive. I don't care if you drink. Just don't drive. Driving sucks. And if you're in the Lehigh Valley, really don't drive. I might be out there, and no matter how much I like you, I don't want to see you on the road. We'll see you next time at the Daily Space Weather, and may that solar wind be at your back.